Good afternoon, my students. How are you? I hope that you'll be okay and your family also okay. I hope you stay in your home. Today we need to talk about our topics that we need to complete also our topics that we finished before closing the schools. So we need to complete our topics with you, Mr. Shadi Eldib from Tabarak Private Schools.
Good morning, our students. How are you? I hope you'll be fine. Today we need to talk about the simple harmonic motion and how can we describe this simple harmonic motion. And also beside that we have to know the equations for this simple harmonic motion. So then simple harmonic motion, we need to define what's this motion. So we got an oscillator. This oscillator is known as in front of you now spring. This spring has a mass at the end. When we pull this spring down, one of the famous force scientists, his name is Hooke, he said now we affect on the spring by a force. This force is directly proportional to the displacement that it cuts by pulling the spring down. When we studied this relation, F is directly proportional with the displacement x, we found that the relation F equals negative kx. Where is k? What's k? K is the force constant or the spring constant. After that we'll know it, spring constant. X, it's what? It's the displacement of object from its equilibrium position, and F is positive when x is negative and vice versa. This is the Hooke's law, F equal negative kx. In more details, look at this diagram. We'll find that the first one, that the spring unstretched. So we'll find that F of the spring equals negative kx. This is the spring constant. And also when we pull it down by displacement x, we found that the force equals to F. But if we doubled the displacement x and becomes 2x, the force also will be 2F. It means that it's directly proportional. So I can say K is the constant of proportionality, and K is also has another name, scientific name, spring constant. So F equal negative kx. The negative sign only tells us that F is what is called restoring force, in that it works in the opposite direction of the displacement. Restoring force, this restoring force due to the pulling of the spring. This law is known as Hooke's law. Okay, now if we need to define this motion, simple harmonic motion, such a motion in which acceleration is directly proportional to the displacement and is directed towards the main position, this is called simple harmonic motion. So we can find that the acceleration is directly proportional to displacement in this type of motion. This type of motion is known as simple harmonic motion. Now, if we need to describe this motion graphically, we have to put in our mind that we have two types of starting point for this motion. Sometimes we can say that the object starts from equilibrium position. Other times we can say that the object starts its motion from maximum displacement. So if the object starts from equilibrium, we can find that the graph between displacement and time as in the diagram in front of you. And the velocity versus time also becomes like this in front of you. Look at this. We'll find that the displacement and time, also velocity versus time graphs related to the starting point for the object. If the object starts from equilibrium, as we know from these diagrams, we have to know in your, or we have to put in your mind that the graph looks like this. And also the acceleration will be in opposite direction of the displacement. If the displacement of the object that starts from equilibrium position starts in positive direction, also the acceleration will be in opposite direction, negative direction. This is by studying the motion of a spring or pendulum. And we know this pendulum, this object, that we have it in a clock pendulum. So this graph is very important to save it in your mind. And how can we differentiate between displacement time, velocity time, acceleration and time? Also, we have here what? We have here the second case for motion, that the object starts from maximum displacement. When the object starts from maximum displacement, we'll find that the relation between displacement and time starts from amplitude, maximum displacement. And the velocity will be zero at this case, because at maximum displacement we'll find that the object is stopped for a moment. It means that velocity equals to zero. But acceleration at this case starts from maximum but in opposite direction of displacement. If the displacement in positive, acceleration will be in negative. Now let's talk about the equations that we can use it in this simple harmonic motion. We have three equations, one for displacement, one for velocity, and one for acceleration. But we have to put it in your mind in these equations in which direction and in which position the object starts. If the object starts from equilibrium position, we have to know that x equal xo sine omega t. And we have to put in our mind that xo here means amplitude. And if the object starts from maximum displacement, x equals xo cosine omega t. Also, we have to know that the velocity for the object, if it starts from equilibrium position, omega xo cosine omega t, but from maximum displacement, negative omega xo sine omega t. But for acceleration, it's very easy because it will be negative omega square x. Also, we have another formula to find the value of velocity. V equals positive or negative omega root of xo square minus x square. And we said it before, xo is the maximum position or amplitude, and vo is the maximum velocity, and also omega angular velocity, but t is the periodic motion, and x is the position, also v is the velocity. This is the famous four equations that we have to use it in finding the velocity and acceleration and displacement for this type of motion, which is known as simple harmonic motion. You have to study it very well. You have to analyze it very well. And you have to know in which direction, in which position the object starts. So I hope you will be fine. I hope you will understand what we explained today in simple harmonic motion. Thank you. See you later, inshallah.
Thank you for your listening, and also thank you for your caring for what we explained, and thanks also for the chairman of our school, Mr. Yunus Rahbi, because he did everything related to make this process very cooperative, related to new technology in education, and how to process this technology to reach all information to the students. So thank you, and don't forget that the homework also uploaded in Moodle in the website of our school.